Hello dear viewers. To start with, I'm going to show you some pictures. Here is an excited boy who wants to go to a trip. He is very excited, but due to lack of fund, he still cannot leave his house. However, if the school sponsors his trip, so he's happy to leave here and go to the school trip. In this case, a funny man going in a particular direction with high energy, if at all he sees a very tasty food like this, he will slow down, change his direction and go and buy some of this tasty food. That is masala dosa, a South Indian dish. Then another point of pictures, set of pictures I will show you about. See here, for example, this is a personification of a negative number. If it is added to the counterpart of the same on the other side of the number line, that is the positive number, then both of them added will give you a 0. That means they actually destroy each other. So all these are some simple ways to compare the interactions of nuclear radiations with matter, alpha and beta particles, the charged particles. This is the second part as a continuation of my last presentation. The contents of this presentation will be alpha particles, what are they, what are beta particles, and what are these interactions, excitation, ionization, Bremstrauhlung and Annihilation. What are alpha particles? Here you can see a cloud chamber used by a physicist to detect the alpha radiations. They are positively charged heavy particulate radiations. They are emitted from the heavy nuclei, just like a nuclear family coming out of the joint family, just to reduce the clashes and improve the peaceful conditions. That's to get stability. Now here it's about a helium nucleus which has 2 protons and 2 neutrons. The 2 in this subscript is for indication of the 2 protons, and the other is the 4 is the atomic mass number, which is the number of nucleons, number of neutrons plus number of protons. It is made up of discrete energies 4 to 8 mega electron volts. This is the equation which shows the emission of alpha 24 particles, and that is where the atomic number of the product daughter radionuclide becomes lesser by 2, and the atomic mass number, that is total number of neutrons and protons, reduces by 4. Just to balance this equation. Then it is followed by gamma emissions. Very short range in the medium because these are heavy particles. Even a paper can stop these particles. It picks up orbital electrons and becomes the stable helium atom. It's highly ionizing and it follows a straight path, unlike the beta particles, as you are going to see, because they are heavy and they are not deflected much even after the interaction with the medium. Now, what are beta particles? They can be positively charged positrons or be negatively charged negatrons. They're called negatrons to just not get confused between the electrons, which actually these beta particles are equivalent to the electrons, which are the orbital subatomic particles. Then when the neutron to proton gets conversion happens, there's a beta minus emission. That is where the Z atomic number is increased by 1 and the atomic mass number remains the same. These are called isobaric transitions. When there's a proton to neutron conversion, it is the Z which gets reduced by 1 in the daughter radionuclide, and the atomic mass number again stays the same because it's just proton to one nucleon to another nucleon conversion. The number of nucleons don't change. Now that here you get a positron. And they are very light as compared to alpha particles, and their mass is very, very much negligible. Because of this, they will collide with the matter to deflect at large angles. And they follow a tortuous path, and their energies are also very variable, and they are not only discrete energies, it's a continuous spectrum of beta energy particles. Now let us see about the excitation. What is it like in the nuclear fields? Here you can see the excited orbital electron jumps to the higher shell, higher energy shell. When the charged particle or even a photon, here we are talking about the gamma photon, interacts with the orbital electron, which gets excited, vibrates, but does not get ejected from the atom, as the energy transfer is not sufficient. As you have remember, I told you about the fund not being sufficient, that the trip cannot be, he cannot go to the trip, the child. And the output of excitation will be molecular vibration, production of heat, infrared, visible light, or UV radiation. There's a collisional loss. This is actually a type of collisional loss. And what about ionization, where the sufficient funding is done? That is, the child can go to the school trip. Here, the collision is between the charged particle and the electron, where the charged particle loses its energy. This is in the form of collisional again. And a fraction of it overcomes the binding energy of the orbital electron to the atom, while the remaining goes as kinetic energy to this secondary electron. It can further lead to characteristic X-rays or Auxerre electrons, and or even cause secondary ionization. They are called delta rays. What it means is they can produce ions again by colliding with the orbital electrons and ejecting them with the sufficient binding energy that they have to counteract the binding energy. Now about the Bremsstrahlung radiation, where there is a diversion of the path of the charged particle because of the interaction with what we are going to see here. The Bremsstrahlung radiation, Brems means breaking and Strahlung means radiation. These are the German words. Beta minus, mostly beta minus radiations that penetrate the cloud of the orbital electrons, encounter the nucleus and decelerate and lose their energy in the varying amounts in the form of Bremsstrahlung radiations. They get deflected because of this kind of attraction towards the nucleus, positively charged nucleus. These Bremsstrahlung radiations increase with the increase in the atomic number of the medium and the particle energy. That means high energy betas can produce more and more Bremsstrahlung radiations. Now here you can see the example of the destruction of both the antiparticles and the antiparticles. This is annihilation. Here you can see the electron and positron coming to each other. As soon as the positron exhausts its kinetic energy, it collides with the nearest electron, and that is the antiparticle of this positron in the medium. And both of these entities get destroyed, annihilated, and then convert into two oppositely directed annihilation photons, each of the energy being 0.511 MeV, that is 511 keV. So that is the rest mass actually of each of these, which have got converted from matter to energy. It's actually the opposite of the pair production that I had talked about in the last presentation. Now, let me summarize what we have seen. The positively charged alpha particles equivalent to the helium nucleus. The positively and negatively charged beta plus positron and beta minus negatron equivalent to the orbital electrons, which are actually the nuclear radiations. Excitation as one of the methods of interaction of these radiations with the matter. Ionization, where sufficient binding energy can ionize or remove the orbital electrons and cause ions formation because of this removal of the electrons. Bremsstrahlung or breaking radiations, the annihilations, where the destruction of electron and its antiparticle positron. So both of them destroy and convert into 2 photon energies of 511 keV each in the opposite direction. So thank you for now and waiting for your questions and feedback.